So a quick bit of feedback for question 6. So a runner completes 100 plus or minus 0.2 meters in 18.6 plus or minus 0.2 seconds. Calculate his average speed and the uncertainty in its value. So first of all, write down what you know. So we know that the velocity is then 100 divided by 18.6, and that gives us 5.376 meters per second. So we can just round that to three significant figures for now at 5.38. We then need to find the percentage uncertainty. Well, to do that, we need to treat things separately. So we know the distance, d, so then that's 0.02 divided by the 100 times by 100%, so that gives us a plus or minus of 0.02%. Do the same for time, but different numbers obviously, so 0.2 divided by 18.6 times 100%, and that gives us 1.07526%. And again, we need to be careful with significant figures so we can round. Things to remember, percentage uncertainties always add. So what we need to do here is we need to add the 0.02, the 1.1, so we've got a plus or minus value for velocity as 1.02%. So to one significant figure, it will turn to 1%. So then the answer is 5.38 plus or minus 1%, and then we need to find 1% of 5.38, which then gives us 0.05. So 5.38 plus or minus 0.05 meters per second. A car accelerates with a constant acceleration from 24 to 31 meters per second, so plus or minus 1 and plus or minus 2, and it takes 9.5 seconds plus or minus 0.1. Calculate the acceleration, and then we need to state our answer with its absolute uncertainty. So then we can write down what we know. So the starting velocity is 24 plus or minus 1, end velocity 31 plus or minus 2, and the time 9.5 plus or minus 0.1. So let's remember that acceleration is change in velocity over time taken. So that's end velocity take start velocity over time, or just v minus u over t if we're writing it in shorthand using the units or the symbols. So that's then 31 take 24, our change, divided by 9.5, so that's 7 over 9.5. So we've then got an acceleration of 0.7368 meters per second squared, or we can round that to one significant figure because we've got a 7 just here, so that's 0.7 meters per second squared. And then we need to find the absolute uncertainty to then find the percentage uncertainty. So the change in velocity, let's find its absolute uncertainty. So one of them is plus or minus 1, the other plus or minus 2, they're the same unit, so that then adds to become plus or minus 3. The change in velocity was 7, so to find the percentage uncertainty in that, it would be 3 divided by 7 times 100, which then gives 43%, quite a large value. For the uncertainty in t, the percentage uncertainty would be 0.1 divided by 9.5 times 100, which gives 1%. Now we always add the percentages together, so that gives us 44%. So then to find the final part, the absolute uncertainty back to acceleration, we know our answer was 0.7 from earlier. We now know it's 44%, so we now need to find 44% of 0.7, so 0.7 times 0.44, and that then gives 0.308. But then to one significant figure, our final answer, 0.7 plus or minus 0.3 meters per second squared. So then finally we've got a cube, and it has a mass of 7.87, and then plus or minus 0.001 kilograms. We know the length of each side, 10 centimeters or 0.1 meter, and we want to find the density. So at this point, remember a cube has equal lengths, its mass, we've got written here, and length just here. So to find density, think about the equation, mass over volume. So let's focus on the volume, just to remember that the volume therefore is 10 centimeters, which is 0.1 meters, which is then the same as 0.1 times 0.1 times 0.1. Now notice, because I've got three numbers here, three significant figures, that's why I've written 0.100 to remind me that the three significant figures carries forward. So to find the actual value in density, mass over volume, we've then got 7.87 divided by 0.1 cubed, and that works out to then be 7870 kilograms per meter cubed. And then finally, to get the percentage uncertainties, well, we know the mass difference would be 0.001 over 7.87 times 100, so that's 0.01%. Volume is length times length times length. Now, there's two ways of thinking about this. you've got to add 3 lots. Now, only because each length is the same, we can multiply by 3. Otherwise, what we'd need to do is find what they are added together separately. But because they are the same, we can do a slight shorthand. So we know that one of the lengths, 0.1 over 10, times 100, so that gives 1%, but there's 3 of them, length, 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 1 plus 1 plus 1. Then we know that the volume error is 3%. So we then know that we've got 3% and 0.01%. Now 0.01% is neither here nor there, plus we've got values with just one significant figure, so we would say plus or minus 3% because it's to one significant figure. So then we'd do 7870 times 0.03, turn it to a decimal, which gives 236.1. And again, think about significant figures carefully. So then we have our final answer, as you can see at the bottom.